All right, we're on lesson 17, which is on the volume of cones and spheres. So the first thing I want to talk about is just a reminder that volume has to do with the space that is inside of a solid. So filling up a fish tank with water. How much water? That's volume, right? So when we measure volume, it's going to be measured in cubic inches, which we've already kind of been talking about when we did that with our prisms and our pyramids. But now we're going to be looking at cylinders, cones, and spheres. So the specific thing that all three of these things have in common is they have to do with circles. So in some way, we're going to have to deal with a diameter and a radius. When we talk about a cylinder, the base of our circle, and I'm going to highlight it, or the base of our cylinder is a circle. And that base being a circle, the area of our base, just like how we talked about that with our prisms and our pyramids, is going to give us a part of our formula. So the formula that we're using for volume for our cylinder is pi r squared, and then we're adding on that h for the height of our cylinder. So to find that volume, we just need to know the dimensions of the radius and the height. For a cone, same idea. The base of our cone is a circle. So the volume formula for our cone is going to be a little bit different. This one is 1/3 pi r squared h. And again, the dimensions that we need are the radius of the shape and the height of the shape. The last shape we're going to look at today is a sphere. And what a sphere is really just a three-dimensional circle. And we're going to just draw a picture off to the side here. So we're going to just do our best. So here's a regular two-dimensional circle. Now what a sphere is doing is it's just creating a bunch of circles all the way around a central point. So if this is the center of my circle here, from that center, I have diameters across, forward, left, right, up, down, everywhere, creating this three-dimensional shape. So the volume of this sphere is going to be everything inside of it, and that formula is going to be 4/3 pi r cubed. And this one is a bit different than the other two. So this one you're going to have to just make sure you recognize that it's a little bit different. So biggest difference, only dimension you need is a radius. We don't have any kind of height here because every single measurement has to do with the radius or that diameter. In this formula, we are cubing our radius, not squaring it. And I'm going to highlight that. Let's go ahead on the next page and actually try using this formula for these three shapes. So the first one says, what is the volume in terms of pi? There are rounding directions. For a cylindrical container with a radius of 3.25 centimeters and a height of 10 centimeters. So we have a radius and a height of 10. We are finding the volume, and our volume formula is pi r squared h. I'm going to let you go ahead, plug those in, see what you get. When you're all set, unpause the video and check your work. Make sure you're doing it in terms of pi. Go ahead. All right, so when we plug this in, so 3.25 squared times 10. Do one thing at a time just to make sure that you don't make any small errors. So 3.25 squared will be 10.56. Let's multiply that by 10. We're not going to multiply by pi because pi is going to be in our answer since it's asking us for it in terms of pi. So 105 0.625 pi, and then this is in centimeters cubed. Let's try the cone. So it says a cone has a diameter of 2.4 inches and a height of 2.9 inches. Find the volume to the nearest tenth of a cubic inch of the cone. Volume formula, 1/3 pi r squared times h. I'm going to let you go ahead and try this one on your own, so please pause the video, plug it in, and solve. When you're all set, unpause and check. Go ahead. All right, so I'm plugging in the radius. Now, they give us the diameter. So the radius is half the diameter, so we should be using 1.2 in our formula. So 1.2 squared times 2.9. I'm going to square my number first, so 1/3 pi times 1.44. And I'm just going to plug everything in very carefully. That's going to give me approximately 4.373096947. And we are rounding to the nearest tenth, so this will be approximately one space after the decimal, so 7 bumps that 3 up to a 4, 4.4 inches cubed. Last one will be our sphere. So it says, when it was blown up, the balloon formed a sphere because it was trying to hold as much air as possible with as small surface area as possible. How much air to the nearest tenth of a cubic inch is being held by a spherical balloon with a diameter of 12 inches? So it's asking us to round to the nearest tenth. It wants to know how much air. Well, air would be filling the space inside of this balloon, so that has to do with volume. And it's giving us the diameter of 12 inches. Volume formula for a sphere, V equals 4/3 pi r cubed. Go ahead and try this one on your own, so pause the video when you're all set, unpause and check. All right, the diameter is 12, which means that the radius is 6. So 4/3 pi times 6 cubed. Make sure that the 6 is being cubed, not anything else. 4/3 pi times 216. Multiply it all together. 904.778642. Nearest tenth, so one space after the decimal, approximately 904.8. And this is inches cubed. All right, that is all for this lesson. Good luck on your homework.